So this is really carrying on from yesterday. We talked about quadratic equations. The idea of completing the square. So we'll come back to this one. And yes, I know we could factorise it, but I'm just using it for the sake of an example of completing the square. So the idea of completing the square. The process is the same each time. So the first thing we do is we grab the constant and we'll move it to the right-hand side. Because really, when it comes to completing the square, we're just interested in the algebra. We want to turn that piece of algebra into a perfect square. So x squared plus 6x, of course, is not a perfect square. The missing term to make it a perfect square is 3 squared, or 9. Or rather, half the coefficient of x squared. Right? Not half the coefficient of x squared, but half the coefficient of x squared. Okay? Because we know that that middle term will be twice AB, if you like. And so half of it will be our number here. So we add 3 squared, creating the perfect square, which is, of course, x plus 3 all squared. And so once we know something's squared, we know that its answer is positive or negative the square root of the other side. So x plus 3 is plus or minus 4, and we get negative 3 plus or minus 4. So there's our two answers, minus 7 or 1. So that's the idea behind completing the square. It is, in fact, where the quadratic formula comes from. If I start with just the general quadratic, ax squared plus bx plus c, and use that same idea. Move, well, needs to be monic. So the first thing I'll do is I'll divide everything by a. So I've got x squared plus b on a, x plus c on a. Now let's move that constant over, minus c on a. Then I'm going to add half the coefficient of x squared. Well, the coefficient of x is b on a. So half of that would be b on 2a. So I'm going to add b on 2a all squared. So that is b squared on 4a squared. But on the left-hand side, when we complete the square, we get x plus b on 2a all squared. If I now create a fraction on the right-hand side, we get something that's starting to look a bit familiar. It becomes b squared minus 4ac all over 4a squared. Now I'm going to take the square root. And so I get x plus b on 2a is plus or minus the square root of b squared minus 4ac all over 2a. So just to move it over, and that is where our quadratic formula comes from. So it's actually the completing the square. All right, so something like this one, x squared minus 6x plus 6. Another way of thinking about it is like this. I know I want to get x minus 3 all squared is equal to 0. Of course, that's not the same. I can't just change the question. If I was to expand out x minus 3 all squared, I would not get plus 6. I would get plus 9. So to balance it back out, I can go minus 3. So that's another way of thinking about completing the square. Now, you could move the 3 to the other side, or you could say, hey, look, I've now got the difference of 2 squares. So it's x minus 3 plus the square root of 3, x minus 3 minus the square root of 3. So therefore, x is either 3 minus root 3 or 3 plus root 3. That's another way of doing completing the square. Rather than moving the term, just write down what the square would be looking at the algebra and then saying, well, how do I balance it out to make it back to the original expression I had? Okay, so 1i, a very biased supporter.